So let's quickly have a look at this midpoint theorem. All right, midpoint theorem is actually pretty cool. Basically, the way that the midpoint theorem works, I'm going to explain it to you, but just it is written on the right-hand side here, so you can see what's going on. The midpoint theorem states that basically, if we have a line segment, so like that over there, that's our line segment, when it's talking about a line segment, and it's joining the midpoints of the other two sides. So that means that this is a midpoint and this is a midpoint over here. So those are midpoints. Let's just write that in. Okay, so that would be a midpoint. Can anyone tell me how I know that D and E are both midpoints? What have they got on the picture that helps us see that that is a midpoint? Don't be scared to get the answer wrong. Give it your best go. They are twinning, not parallel lines, although parallel lines are going to be involved in this theorem. Yes, so D and E are definitely midpoints. So the way that we know is because they've shown us with these little lines. So those two little lines over there, they mean that that line and that line are equal to each other. So that is what that's saying. Those two little lines are telling us that BD is equal to DA. And if those two are the same as each other, then that means that D would be the middle point. Okay. And likewise, on the other side, this line over here and this line over here, they're telling us that that line and that line are the same length as each other, which would make E the midpoint of that line. Yes, Nomaza, how can I help?
Hi.
Hi.
Sorry, ma'am. I was just going to ask. So like you weren't talking about like the yellow line. You were talking about the one that you just highlighted in green.
So the green line is being split up into two to create the midpoint D, and the blue line on the other side is being split up in two to create the midpoint E.
Yeah.
And then the yellow line is just joining those two midpoints.
I guess like I'm a little lost. Just a little bit. Just a little bit.
That's okay. That's okay. We can try and break it down a little bit. Don't panic. Let's try and break this theorem down a little bit, guys. Hold on. Okay, let's have a look on the left-hand side. Left-hand side, we've got these two lines. Well, we've got this line over here. Let's have this nice little yellow line that joins those two. Okay, these lines over here and here are telling us that this distance is the same as that distance. So it's saying that BD is the same as DA. And because that is the case, that makes D the midpoint of BA. Okay, so D is the middle of BA. Now, if we take that logic and we put it on the other side, okay, this line over here and this line over here, they're telling us that they're the same, which means that this line and this line are the same. So AE is equal to EC. All right. Oops, got a bit excited over there. And so that makes E the midpoint of AC. Okay. Is everyone happy up to that point over there? Good, good. Nomaza, are you feeling happier with what I've said so far? Where have you gone?
Yes, ma'am.
We're all happy so far. Excellent. Okay, cool. Okay. Midpoint theorem states that when this is the case, so when we have the situation where the two lines being broken up in half and we've got these two midpoints, and we draw a line connecting those two midpoints. So in this case, that line that we're drawing to connect them is DE. Okay, when we have a line that connects those two midpoints, then this line would be parallel to this line. And whatever length this is, this will be double the length. So for example, if X was 10, then BC would be 20. So that is what the midpoint theorem is saying. The midpoint theorem is just saying if we have a line that is connecting the middle points of two sides of the triangle, then this line will become parallel to this line, and this distance will be half of that distance. Hit me with questions. I'm ready. Shaden.
Hi, ma'am. I just wanted to make sure so that DE is double BC, basically.
DE is half of BC.
I mean, sorry, yes. That way, yeah.
Yeah. You got there though.
Yeah.
Okay. Anyone else wanting to check anything? Michael, what are you feeling confused about? Or were you answering someone else that I missed something? So the signs are the hints. So the signs, yeah, exactly. The signs are there to tell us that those two sides are equal to each other, which make us know that D and E are midpoints, and then we know we could be doing the midpoint theorem. As far as I know, the trigonometry has already been done. I think so those lessons should be online. If you would like to take a screenshot of this, please feel free. We're going to do an example where we use the midpoint theorem, and we also use some of the logic that you've been learning with this whole idea of Euclidean geometry. So take a screenshot and then we can get going. I'm not sure if functions have been done yet. I think the rest of the class would know more than me. I'm just your substitute for today. Okay, thank you guys. I don't know what these are like. It's like won't let me move. It just wants me to be writing. Okay, it's fine. Okay, so let's try and do an example of this midpoint theorem. So let's sort of break things up a little bit. Firstly, we can see that this is equal to that, okay? And this is equal to this. So that means that Q and R are midpoints. Okay. If they are midpoints, what does that mean about QR and ST? What can you guys tell me about QR and ST if those are midpoints? Tell me anything you can tell me. Good, good, good. They're parallel. Okay, so we can say that QR is parallel to ST, and the reason for that is the midpoint theorem. Okay, what else can you tell me about that? So I'm just going to draw that in because now we know that they're parallel. Yes, beautiful. So QR is equal to half of ST. And that is, again, we know that because of the midpoint theorem. Okay, now in this case, they're telling us that ST is X. So that's there to help us. Beautiful, guys. Some of these answers coming in are awesome. I love it. Okay, so we can already see a whole bunch of stuff. Now, if we just take a moment to just kind of write that out as like a little shopping list to get ourselves clear and know what's going on, it sort of just helps us know what the situation is. But some of the answers that came through the chat were awesome. So we could actually jump straight into saying that X is going to be equal to 28. And our reason for that could be the midpoint theorem. So if we didn't write those two lines at the top, we could actually just start with saying X is 28, midpoint theorem. So now we know that this is 28. Okay. Now, we have to figure out why. We have to figure out this angle over here. Who has a suggestion to me? So you could write given here if you've already written it there. But if you haven't written it that it's the midpoint theorem, then no. Who has a suggestion on how we can get, so how we got to 28 is because we know that this line over here is going to be half of this line over here. So if that's 14, then x must be 28. Who has a suggestion on how we can start figuring out y? I did see an answer of y being 60 degrees, but that isn't right. So y is not 60 degrees. Let's see. Mwande, can you help me find y?
So we have to use like the total degrees of a triangle.
Okay, good. You do, definitely.
So that means, sorry, I actually forgot the angle for the total angles in a triangle. I actually forgot.
So they have to add up to 180?
Okay, they add up to 180. So that means on Q, that means y equals 80 because, all right. It's
no, that's 100% right. You're 100% right. It definitely is equal to 80. Like 1000% right. We just have to show a couple of steps to show that we can get there. We just can't jump there in one step, but that's 100% the right answer. So guys, the one frustrating thing about geometry and Euclidean geometry with maths is that it all has to be very specific. It has to follow a very specific structure and we can't skip steps. If we skip steps, then they don't give us the marks. They're very rude about that. So there's lots of different ways you could go about this. I think the easiest way would be first to find this angle over here. So we could first say that angle PQ, let's just write it over here, angle PQR would be equal to 80 degrees. And our reason for that would be, let me just write this the same way you've been doing, sum of angles in a triangle. Okay, so now we know that that's 80, where that little blue dot is. And then we can jump to saying y. So then we can say, therefore, y is equal to 80 degrees because of corresponding angles when QR is parallel to S. So how we got to 80 is that all three of these angles have to equal 180. So we said 100, well, yeah, let's write it like this. We said angle Q that we're trying to solve plus 40 plus 60 has to equal 180. Shaden.
Ma'am, I understand what you did was right, obviously, but I was under the impression that y would be 40 because SQ is equal to QP.
Okay, so now the only, I hear what you're saying. That's a very normal thing to think. That the only time that that's the case is if, let's just draw a little triangle over here. Okay, so when we use that rule, it has to be within a triangle. So do you see how SQ and PQ are on a line?
Yes.
Okay, so if it was a triangle, then 100% you would be right. So let's imagine that this was P and this was Q and this was S. Then absolutely this angle would be equal to that angle.
Yeah.
But only when it's a triangle, not when it's a straight line.
Okay, I see. Okay. I see. Thank you.
No worries. Okay, guys, does anyone have any questions about what you're currently seeing on the board before we jump down to some others? Don't feel embarrassed to ask. Ask away, please. Exactly. The triangle is equal to 180 degrees. So you could have also worked out this angle down here and done it a slightly different way if you wanted to. That would have also been totally fine. Does that help? Think someone needed it to be moved? Does that make it easier for you to see or not? Let me know. No, sweetheart, triangle always is 180 and a quadrilateral is always 360. Yes, so angle T is still unknown, but we could have worked out angle T because angle T would be the same as angle R because they're corresponding angles. So we could have first found angle T and then found Y. So Y, this angle here, is equal to this angle here because of those parallel lines. So they're corresponding. It's the F rule. So when those two lines are parallel, then this angle would be equal to that angle. So remember, they add up to 180 within a triangle. So this triangle over here would equal 180. And then if I had 40 plus 80 plus 60, that big triangle would also equal 180. So we only add up the angles that are in the vertices. I'm messing it up. It's a kuchle, but there's no L.
It's okay, ma'am.
Can you say it for me properly so I don't mess it up again?
Lindokuhle.
Thank you. Okay, how can I help?
Ma'am, I wanted to ask because when you're looking at the triangles, these are two triangles when we add the line in between QR. So how do you say it's the numbers inside are equals to 180 because the line in between is dividing the triangle?
Exactly. So like this, I'm going to just color it in over here, that blue triangle over there. If I add up the points of those blue triangles, the blue triangle, it needs to equal 180. And if I had this big pink triangle, if I added the points of the pink triangle, it would need to equal 180.
So now we are looking at the pink triangle, not the blue one.
Yeah.
Thank you, ma'am.
No problem. Goodness gracious, there are a lot of names here.
Sorry, ma'am. Hello.
No problem. How can I help?
Oh, ma'am, I'm confused, ma'am. Ma'am, how should I know, ma'am, that it is 360 or is it 180, ma'am?
Okay, so that's something that you just, it's one of those things that you're just going to have to know. So you always have to know that a triangle adds up to 180 degrees. So let's just draw a little triangle over here. Like if I have X, Y, Z, X plus Y plus Z, that has to equal 180. And if I have any kind of quadrilateral, X, Y, Z, W, that always is going to equal 360. So that's just one of those things that you have to just know it.
Oh, thank you, ma'am.
No problem. Okay, I feel like we have come to the end of our questions, which is good. Okay. Please don't forget to take a screenshot if you were wanting one. Welcome back, Nelly. So excited to see you.
Oh, thank you. I had to move to another area. I'm sorry, I got kicked out.
No, it's okay. Don't worry.
Oh, thank you so much.
Okay, let's move on down to some other questions to see how we can put them all together. Okay, whoop, not those, these. Okay, so question 5, that's chilling over here. Whenever we do a Euclidean geometry question, we kind of want to put some things into the picture that help us as we work through it. So they're telling us that this is a parallelogram. All right. What can you tell me if it's a parallelogram? What does that tell you about this picture? Give me any facts you can tell me about this picture. AB is equal to DC. Beautiful. What else can you tell me? Keep them coming. Opposite sides are equal. Good. So that side's going to be equal to that side. Yes, opposite angles are equal. So if this is 120, this is 120. Good. Yes, parallel. Those two are parallel and these two are parallel. Beautiful. Yes, the diagonals bisect each other. So that is being dissected and that is being dissected. bisected, not dissected. We're not in a biology class. Sorry. Good. And they intersect at that midpoint. And opposite sides are congruent. Beautiful. And then all of them inside, the sum of my angles is going to be 360 degrees. There should be a letter for the middle. Let's make it O. Okay, so let's try and go through these questions. Can you try and work through them by yourself? So give question 5.1 a try. Be careful to show all of your steps as you're working. Remember, you can't always just jump straight to the answer. Sometimes you have to show more than one step. Whenever you give your statement, you have to give a reason. So in geometry, we give a statement, we give a reason. So all of the things that we've put on the picture are there to help us. And then we kind of use what we've given to make our points. So give at least 5.1 a try. It would be great if you could give 5.3 and 5.4 a try. And then we can chat about what answers you got. Also, welcome to put your answers in the chat as you work through it. Michael, what's the question about the rhombus? Y is not going to be 35. X is 35. Nice. Good. Good, good, good. Keep them going. Then we need to find Y. Good, Princess. Yes, that's right. It's okay if you're feeling a little bit lost. Don't panic. I promise I'll go through it nice and slowly. I'm going to give you a couple more minutes to give this one a try, and then I'm going to start working through 5.1 with you. Y is not 85. It's okay. Don't panic. You can do co-interior. Nice job, Princess. Okay, you're on your last minute for this question. You're doing really nicely though, guys. You could do vert up, but only over here or here. Okay, let's start working through this. And now whenever we have parallel lines, our brain needs to think of, so as soon as we have parallel, oh gosh, I'm highlighting things. There we go. As soon as we have parallel lines, we want to think of fun. So F is for corresponding, U, that's for co-interior, and then N is our alternate. So when we have parallel lines, we want to look for these three letters. We want to be like, can we find an F? Can we see if there's a U? And can we see if there maybe there's a Z or an N? Okay, so if I have a look here, I can say, well, this is one of my parallel sides, and that's one of my parallel sides. And I can join that to make a Z. So Make this a little bit neater. There we go. And if we've made a Z, that means that this angle here needs to equal this angle here because they are alternate angles. So the first thing we could say is we can say that X is equal to 35 degrees. And our reason for that is going to be alt angles are equal. And whenever we use alt angles, we need to say which sides are parallel. So we need to say AD is parallel to BC. Okay, so that's our first thing. Now we know that this is 35. So we've done our N or our Z. Let's see if we can find another letter. Don't think an F is going to help us in this one, but maybe we can use the U. So if we look at this parallel line over here and this parallel line over here, we can create a U. And when we create a U, this angle here plus these two angles here need to equal 180 degrees. So we can say that 120 plus 35, because that was X, plus Y has to equal 180 degrees. And our reason for that is going to be co-interior angles when AB is parallel to DC. And that means that Y is going to be 180 minus 120 minus 35, which is 25 degrees. How did that go? Those of you who are feeling a little bit lost, does this make it feel a little bit easier? Do you see where you made mistakes maybe? Oh, good. That is like what I like to hear. Good, 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 good. Remember, making mistakes in maths is a good thing because it means we're learning. So don't stress. Excellent. Okay. All right. So that is 5.1. Can you give 5.3 a try for me? And 5.4, you can do them at the same time because they kind of relate to each other. So before you jump into it, what is this symbol over here? When we have those three lines that are underneath each other, what does that symbol mean? Congruent, good. Okay, so those three symbols over there, that means congruent. And remember, congruent means that they are exactly the same in every way. Oh my goodness, guys, my cat is like completely obsessed with this plant. He just keeps on finding it and eating it. I don't even know if that's healthy. Okay, so for 5.3, you're saying, are those two triangles congruent? And then the second one, you're going to give me your condition. So triangle ABC, I'll highlight it in a color. It's going to get quite messy. So that's triangle ABC. And you're trying to see if it is congruent to triangle BDC. This one over here. So let's find out. It's okay, don't worry. Hi, Lucille, how can I help?
Hi, ma'am.
Hi, sweetheart, how can I help?
I want to answer the question.
Oh, brilliant. Talk me through. What did you get?
I said that BD is the common side.
So BD wouldn't be a common side, but BC would be a common side. Oh, I think that the network is breaking you up there, sweetheart. So common sides are one of those things that can be a little bit nasty. So it's a very normal mistake to think that sort of BD would be common because it's sort of in both triangles. But if it's a common side, then basically like my highlighter has to be on both of it. So that would be a common side, absolutely. Okay. And we know that this angle is equal to this angle because it's a parallelogram. You guys told me that right in the beginning. So we know that those two are the same. You know that this angle is 35, and you know that this angle here would be, oh gosh, not 30, 25 because of your Z, okay, because you worked that out when you worked out your Y over there. So let me just put in all of those angles so you can have a look-see. Yeah, it was a bit sneaky, this one, hey, because if you look at it, okay, so if you, our instinct is to want to say, yeah, obviously, right? This angle over here, that together is going to be 60, right? Okay, and we know that this side is the same as that side, and we know that this is a common side. So we should be looking for side angle side. That's what we should be looking for because we've got the two sides, but the angles in the middle of the two sides that are equal are not the same as each other. The one is 120 and the other one is 60. So these are not congruent. I'm worried I've taken the wrong triangles. A, B, C, B, D, C. No, I took the right triangles. Nwazi, talk to me.
Hey, ma'am.
Hi.
I was asking, why isn't BD common?
Why isn't BD common? Because BD isn't the full line of both of the triangles.
It isn't.
So it's the full line of my pink triangle, but it's not one of the sides of my blue triangle.
Oh, okay.
Do you see that?
Yes, ma'am.
Okay.
Thank you.
No problem. Yeah, sure, guys. So sometimes when it comes to congruency, although this sounds a little bit crazy, sometimes it's actually easier to kind of just draw your triangles out separately, and then it's easier to see what's going on. So I'm just going to show you what I mean by that. So I'm going to quickly draw the first triangle. So that's my blue triangle. That's A, B, C. And guys, you don't have to be like winning any kind of beauty contest when you draw these. It's literally just a way for you to organize your thoughts. All right, so we've got our pink triangle over here, and we've got our blue triangle over there. Now, the first thing when we do this is, those of you who are wanting to say that BD is a common line, what makes drawing it out like this nice and easy is you can see that BD isn't in both of the triangles. There is no BD in blue, but there is a BC in pink, and there is a BC in blue. So BC is the common side. That's the one that's in both of them. So sometimes drawing out your triangle separately can really help. Okay. Now let's try and fill in the information that we know. Okay. We know that this side is the same as that side. BC is BC. That means that this side is the same as that side. No problem, guys. That's what I'm here for. We know that this is 60 degrees because of co-interior angles. Okay, so we know that that's 60 degrees over there. And we know that this one over here is 120. There we go. So without even having to do anything further than that, we can see that they're not congruent. So it's 120 because it's in a parallelogram, and in parallelograms, the opposite sides are equal. So if this is 120 here, then this is 120 here. Exactly. So hopefully, like, drawing it out has helped some of you see how to do it in a little bit of a clearer way. Sometimes what happens with these questions is they feel so overwhelming, and there's lines everywhere, and there's like drawings, and you've colored things in, and it's all a big mess. And so sometimes just drawing it out really just sort of helps clear up what's what. Yeah, of course. So yes, these are not congruent. And so to state the condition of congruence, they are not congruent. Mateo, how can I help?
Hi, ma'am.
Hi.
Ma'am, I have a question.
Sure.
Ma'am, you see, like, you know, like how, like, one side, like the top side that is parallel to the bottom side, like the bottom side, like let's say the top side equals X, and then the bottom side that's parallel, it equals to 2X.
Oh, okay. So that's only the case in a triangle. So if this was X over here, then this would be X over here.
Oh.
So that's only the case when we're dealing with a triangle and we're dealing with the midpoint theorem.
Oh.
Okay.
Yes, ma'am.
Okay. Good. Good questions, guys. It's good that you're asking questions. For those of you who are saying SAS, SAS is what we would be looking for, but it's not SAS because they're not congruent. It did feel like a trick question. I agree. That's why I thought that I maybe had chosen the wrong triangles, but it is what it is. All right, take a screenshot if you would like. I know it's a bit messy. I saw someone had just joined. That must have been a very scary place to just join. But take a screenshot and we can maybe move into one more question before quiz time. I do love questions because I love hearing from you guys. Roro-san, how can I help? Yeah, I can imagine.
Ma'am, actually, can I just, I was gonna ask, so in a test, if they ask, the first one was a trick question. So if it's because they're not congruent, would we get both the marks if we stayed not congruent?
Yeah, I think you would in this case.
Okay, I was just checking.
Yeah.
Thank you.
I think it was a bad question on the the test side of it, but yeah, I'm pretty sure they would just give you that. So the 60 is just to show us that it's not the same as the 120, basically. Okay. We have got a midpoint triangle question to get going on. Woohoo! Okay, so the first one is calculating the angle of ADE. So that's that angle over there. That's the first part of your question. And the second part of your question is they saying if AB is equal to AC, so if this line here is equal to that line there, calculate the angle of CAE. Okay. Mother, don't even start with me right now. Bonolo, how can I help? Oh, I can see you unmuted, but I can't hear you. It might be a network thing. It might be a headphone thing. Yes, guys, D, I'm liking it. Good. I'm gonna give you a little bit more time to give them both a try because I want you to try 6.1 and 6.3. Oh, do I have a, am I missing someone's hand? Don't forget to put your reasons there, guys. Bonolo, I tried to unmute you. It did unmute you, but then we couldn't hear anything. Lihle, have you got an answer for us?
Hi, ma'am.
Hi.
Ma'am, I just wanted to ask, what does SAS mean?
SAS stands for side, angle, side. So it's one of our rules of congruency. If the triangles have the same side, the same inside angle, and the same next side, then we would use SAS as a reason of congruency.
Okay. Thank you, ma'am.
No problem. Okay, great answers coming through over here. Now, I love that you are saying the corresponding angles, which is 100% right, okay? And we can jump straight into that because they've told us that those two lines are parallel. If they hadn't told us that those two lines were parallel, we would first have to prove that by using the midpoint theorem, okay? But they have, so that makes our life nice and easy. So all we have to do for 6.1 is say that angle ADE, I saw some of you said D1 and D2, that's fine. Just make sure you actually write it on the picture. If you don't write it on the picture, it's a problem. So ADE is going to be equal to 45 degrees because of corresponding angles. And then whenever we use that, we have to say which ones are parallel. So we're going to say DE is parallel to BC. Okay, so now we know that this is 45 degrees over here. Now, the second part of the question is they saying if this side is equal to that side, what does that make A? I wanted to ask if the triangles would be similar to the previous question. Oh. No, they wouldn't be similar because their angles weren't the same as each other. A is common, but we're not trying to prove that these are congruent. We're just saying, so what we're looking at is we're looking at our big triangle now. We're saying AB is equal to AC. That's what this part over here is saying. If that is the case, then what is angle A? So think about it like this. Imagine you were just given a little picture like this, and they said A, B, C. They told you that this side is equal to that side, and they told you that that is 45 degrees, and they wanted to know what that angle is. Think about it like that. That'll make it a little bit easier. I'm looking up to the gods to help me. So start by finding this angle and then find that angle. Great. Great job, guys. I'm going to give you 1 more minute. And then I'll write the answer on the right-hand side. Will questions like this be in the exam? Probably, depending on what you have done in class. We are going to use sum of angles in a triangle, but we're also going to use another reason. So we have to start with finding angle C. It's one of these really irritating rules with maths, where long ago you actually used to jump straight to A and you were able to give one reason, but then they changed the rules and now we have to do it in 2 steps. So for 6.3, we're going to start by finding angle C. We're going to say angle C is equal to 45 degrees, and our reason is angles opposite equal sides. So that's the rule that we use when we have an isosceles triangle. I know it's an irritating rule, but it is what we have to use. So the bases will be the same as each other because they've told us that this line over here is equal to that line over there. So then we know that this must be 45. Once we've written that, then we can find A. So then we can say, therefore, angle A is going to be 180 minus 45 because of sum of angles. Oh, sorry, I didn't see that hand. Let me just finish this and then I will get there. Sum of angles in a triangle. And let's just quickly figure, oh, where did your hand go? So then A is going to equal to 90 degrees because 180 minus 45 is going to give us 90. Does anyone have any questions about what you're currently seeing? Take a screenshot if you would like. Oh, you guys, my cat is saying hello to you all. Stephen. Yes. Hi, Stephen. How can I help?
Ma'am, can you hear me?
Yes, perfectly.
Ma'am, I wanted to ask you, ma'am, if you kindly please explain A, how you got A, because I wanted to ask you because A, B, you each had, for example, A, B had one line and then A, E had two lines. And I wanted to ask how then did you get 90 degrees? Because how I done it was, I said AB is a double of AC, which then I got C equals to 90, which I said 45 plus 90, which gave me, if I'm not mistaken, 135, if I'm not mistaken. Correct me, I might be wrong on that.
No,
and then on top there I got is it 55? That's let me check. Yeah, on there on A, then I got 45.
So you are absolutely right. This is a one line and this is two lines. So it's not saying that they're the same as each other. But the question down here tells us that this line AB is the same length as AC. So that's what I've drawn over here. That's AB, that long pink line, and that's AC, that long pink line. So
yes,
just to have it as a different line, we can make them three, because then it's not the ones or the twos that are in that picture. So they told us in that question that those two are the same length as each other. So if those two are the same length as each other, then the base angles have to be the same. So if that's 45, then this has to be 45 over here.
Okay, now I get it now.
Thank
Thank you.
Sense? No problem.
Yeah, it does. Thank you.
Good, good. Would it be wrong if I said, yes, you wouldn't be able to see angles on a straight line. We're only able to use angles on a straight line when we are using a straight line. So like, for example, if this was 120 and that's X, you could say X is 60 because of angles on a straight line. So would E be, yes, E would also be 45 because of corresponding angles. Absolutely. Good. And let's just, while we're running at this, if this was 15 centimeters, and this is the last thing I'll tackle your brains with. If that was 15 centimeters, then what would be CB? If DE was 15 centimeters, what would be CB equal to? Yes, guys, 30, nice. Woohoo. Guys, it's been a joy. I always enjoy teaching you. Thanks for chatting. Thanks for your questions.